không? Đó. Thế thầy mới kể là cái khóa đầu tiên các bạn rất thích thi tự luận. Trước đây thì thầy chỉ cho thi viết, xin lỗi, thi tự luận. Thế còn cái mà thi tự luận thì mỗi một cái đề của thầy nó chỉ có 2 câu thôi, 2 hoặc 3 câu thôi. Thì các bạn ấy kêu rất là kinh, đặc biệt là các anh chị ICT đúng không? Thầy vừa phải rồi, em cả đời em chả cần dùng cái khóa, thầy bắt em thi tự luận làm gì? Thì vấn đề thì trắc nghiệm thì ok, thì trắc nghiệm. Thế thì cái năm đầu tiên thầy cho thi trắc nghiệm thì thống nhất với nhau, thầy trò thống nhất với nhau trên lớp như này này. Là ông nào thi đáp án đúng thì được điểm, đáp án sai thì trừ điểm. Và có một tên nó được kỷ lục, và nó được điểm trừ 12.
Trừ 12.
Trừ 12.
Nhưng mà sai hết ai không điểm hay sao lại?
Nó bảo là sai bị trừ điểm. Đó, âm 12 điểm. Và cái phổ điểm nó thật sự nó ra một cái hình sin luôn, perfect. Đó. Thế là cuối cùng là không dùng được cái kết quả đấy, phải thống nhất với các bạn ở trên lớp là đáp án sai thì không có điểm. Nhưng mà vẫn còn một trường hợp mà trong từ hồi dạy gen chem đến giờ biết mới có một trường hợp thôi, là cậu đấy là cậu ấy chơi cái trò bãi mìn ấy, thì nó phải là vô địch, nó tránh được tất cả các bạn mìn. Trắc nghiệm là 40 câu không đúng một câu nào luôn. Tức là bạn này phải đi vào công binh, nó tránh được mình thì thôi rồi đúng không? Mấy kiểu gì cũng không ăn được cái đó, sợ thật. Kinh hoàng. Nhưng mà không phải, nhưng mà các em biết là có một năm điểm cao nhất không phải là ngành hóa đâu nhá. Điểm cao nhất là ICT. Có một năm ngành điểm cao nhất là gen chem là ICT. Và tại vì trước khi cậu là chuyên hóa như vậy. Okay, so I'm already, shall we start? Okay, so in the last section we end up the question of energy conversion, the law of energy conversion. Okay, in general we say that energy cannot be produced, cannot be disappeared. It can be only transferred from this form to another form. Okay. And the second thing you need to remember is that there is no perfect engine. That means there is no energy conversion that can provide 100%. So most of the time, all of the time, when you make the energy conversion, you will have an energy waste. Okay? So this is important information. So let's warm up a little bit. You know about this thermal power plant, right? Nhiệt điện. So historically, the first thermal power plant has been installed in Hải Dương province, in Chí Linh. Anyone come from Hải Dương? No? Nhà máy nhiệt điện Phả Lại. Okay? It has been built with the support from colleagues from Soviet Union. So now, let's warm up with one question. What is the energy conversion or transformation happening in a thermal power plant? The kind of question you will have in it. First, chemical energy to heat. B, chemical energy to electricity. C, chemical energy to chemical energy. D, A, B, C are all correct. E, A, B, C are all wrong. What could be the correct answer? Let's take 2 minutes. answer?
Alright, so my answer is both A and B.
A and B, how about C?
C. So to see that when the form of energy didn't change, so how did how can I think that from the C is it had no relevance, so something like that, no relevance.
Anyone have the same answer to your correct? You have the same answer? Okay. Same answer. 3. Okay. At least 3 guys fell already. Now, the question is A, B correct already, okay? How about C? How about C? So, your friend said that C has no relevance. Chemical energy, transfer to the chemical energy has no meaning. So let's look about the process of thermal energy, thermal power plant, right? You take the charcoal, the carbon compound, right? Or biomass, whatever you want. You burn it, so you create heat, right? So the first is that you transfer from the chemical energy you store in charcoal into heat. And then when you have heat, it will boil the water, right? So you transfer the water from liquid to vapor water. And then when the vapor water comes up, basically in that process you transfer from the heat to kinetic energy, right? Because water vapor moving, so it makes the engine, the turbine, turn like this. So when the turbine turns like this, it will convert the kinetic energy to electricity, right? So basically you have at least chemical energy to heat, heat to kinetic, kinetic to electricity. So A, B correct. But I emphasize also that there is no perfect engine. Okay? You have some weight somewhere. Weight energy somewhere. So to answer this question, A, B or C, so B, A, B correct. Okay? So now the question is C correct or not, relevant or not. So let's look at this one. What you want really in this chemical reaction is that you take the carbon, you burn, you generate CO2, right? So if you burn, you generate all the CO2. Let's say the energy you store in this carbon is 1 megawatt. You generate to 1 megawatt of this process through the heat, it will be perfect. So in that case, there is no great energy, right? But it not happen like that. The real action is that the real energy conversion in this thermal power plant is a maximum 40%. All over the world, no one can make more than 40%. When we say that no more than 40%, maximum 40%, then you should ask question that where is go other 60% of energy? Huh? So who picked this 60% of energy where? The real problem is following. You have CO2 as the product to 1, but you have what compound we call the fly ash. In Vietnamese we call cho bay. Okay? Because it's very thin and it can fly easily in the atmosphere. So this energy stored in this chemical compound take part of 60% energy waste, you don't have 100% energy conversion. So basically, the question C is also correct because you convert chemical energy here, also in the chemical energy you store in this flying ash. So A, B, C are all correct. Is it clear?
Yes.
So, here to ask this question, just to share with you one of the big issue in Vietnam now. Because in Vietnam, what kind of electricity we do have? Hydropower, right? You get. Thermal power, right? You get. And what else? We have a wind power. Yes, we have in Bạc Liêu, right? And we have solar power. Okay? But the main percentage energy consumption we have today come from hydropower and thermal power. And when we depend on thermal power, each year we generate a lot of this fly ash. And for the moment, we don't know what can we do with this weight. Inside you have 60% of energy, almost stored, okay? And you have a lot of this powder. For the moment, we don't know how to use this more efficiently. So if you want to have some innovative idea to start up, do a big business, this would be something you can consider. Okay? If you ask me, Phong, can you propose something? I don't know. Okay. So let's move on. We talk about the chemical property. So the chemical property are excited by matter as it undergo change in composition. And all substance will exhibit physical property that can be observed in absence of any change in chemical composition. So it says that if you have a change in chemical composition from one substance to another substance, one compound to another compound, you have chemical change. But if you have such change in other phenomena, other observation, for example, change in color, change in the phase, but the chemical compound will be the same between the same compound, then you have physical change. Okay? The physical property can be color, density, melting point, boiling point, and so on. Okay? Electrical conductivity. In any physical change, so basically we talk about the three physical states, no change in chemical composition. So that's the first side. But in any chemical change, one or more substances are used up. At least one should be consumed. Okay? And then one or more new substances are produced. In principle, you convert from one chemical compound to another chemical compound. And during the chemical change, energy is absorbed or released. If the chemical change absorbs energy, then you have process we call endothermic. That means receive heat from the environment. So when we receive heat from the environment, that means the environment will be cooled down. Okay? And when the energy is released, that means the chemical compound release energy, we call the process is exothermic. That means it will release heat to the environment and to heat up the environment. Okay? In short, if you want to warm up in the winter time, you need to find out a process, chemical process, which is exothermic. It releases the heat when the chemical reaction happens. If you want to cool down during the summertime, you should find a process which is endothermic, that absorbs energy to cool down the atmosphere. Okay? That's it. So, the red highlight here is energy is absorbed or released. But what will happen if the energy difference is zero? The energy released or absorbed, you can imagine like following, because we are talking about the energy. So imagine that you have this potential energy. So you have camber A at this potential, at this energy potential EA, and you have camber B here, EB. Okay. So they are not at the same energy potential. Okay. So we call they are not in the same chemical potential because that potential energy represent the possibility to make a chemical reaction. So we call them chemical potential. Okay? A and B are not at the same chemical potential. If you start from A, you go down to B. So you go from A to B. The process will be exothermic because you go from higher energy to lower one, right? So the potential energy needs to convert to something else to release to the environment. So in that case, the process will release energy we call the exothermic. Okay? Here, exothermic. But if you do the inverse, that means you start from a lower energy, you go up this side. So you need to absorb energy to bring it up, right? So in that case, the B to A will be endothermic because it absorbs the energy. Okay? So naturally, if you have this point, it will fall down. So if you have a higher chemical potential, it will have tendency to low down, to fall down to a lower energy potential. So the reaction become, we call spontaneous. If I keep it A4, spontaneous. Okay? But if I do inverse, that means I have something at a lower potential energy. If I want to bring it up, I need to bring like this. Okay? So I need to put energy up. Is it clear? So what will happen? Do you have any chemical reaction? If you have C and D at the same energy potential. If you have C and D at the same energy potential, so when you move from C to D, you don't need energy, right? It will be like this. And D to C will be freely like this one. Is it correct? Yes or no? So, I explained to you that in the case of A and B, they have different energy potential. If A have higher energy, fall down to B lower energy, becomes spontaneous, easy. And it will release energy because of the law of energy conservation. If you bring from B to A, that means you need to push up. You need to put energy up to bring it higher energy level. The process becomes endothermic, you need to have energy input. Okay? My next question is that you can imagine some scenario where A and B, for example, in this case C and D, they are at a perfectly equal energy potential. Okay? Then, by the logic thinking, I would say that C to D or D to C will be no energy cost, right? Because energy difference will be zero. Is it correct? So what do you think? In that case, where the C to D and D to C will be spontaneous in both sides. Yes or no? First question, do you know any chemical reaction where C and D are the same potential energy? Do you know anyone? Yes or no? No, right? Actually, there are. So, the reaction will have different energy equal to 0 like this with this one. 2s plus 2 electrons provide F2 with delta G equal to 0 kilojoule per mole. So the process is exactly at the same energy potential. Okay? Only one example we know. 2s plus 2 electrons become hydrogen. So the next question is, if then can consider here 2s plus and here hydrogen. Then you can imagine that if you have hydrogen, it will spontaneously push to provide 2s plus, right? Because delta G you require 0. You don't need any energy to make it happen. Is it clear or not? Logic or not? Okay? And in the inverse way, if you have 2 protons, you put in 2 electrons, you will make hydrogen spontaneously because delta G equal to 0. Potential energy equal to 0. By logical thinking, is it clear or not? So, do you have any difficulty to imagine this scenario or not? Thầy có cần giải thích bằng tiếng Việt không?
Dạ có.
Okay. Exception, okay? Let's say, nếu như mà chúng ta có một cái hợp chất ở cái năng lượng cao hơn, chuyển xuống một cái hợp chất có năng lượng thấp hơn, thì như là các cụ gọi là nước chảy chỗ trũng, đúng không? Quá trình đấy là quá trình spontaneous, tức là quá trình nó tự động xảy ra, đúng không? Các em cứ để vật ở trên cao thì nó tự động nó sẽ rơi xuống, đúng không? Và khi mà nó rơi xuống như thế, từ trên cao xuống thấp, bởi vì định luật bảo toàn năng lượng, nó sẽ phải release ra, nó sẽ phải phát ra một cái năng lượng tương đương với cái năng lượng khác biệt giữa hai cái trạng thái đấy, đúng không? Ok chưa? Và cái quá trình đấy là quá trình tỏa nhiệt, đúng không? Còn trong cái trường hợp ngược lại, nếu như mà em đang đi từ dưới thấp mà muốn lên cao, nhìn thấy các anh thợ xây, các anh tung gạch vào, đúng không? Rõ ràng là bên gạch từ cái level thấp hơn, năng lượng thấp hơn, nó muốn lên tầng cao hơn thì nó phải tung thôi, chứ để gạch đấy nó tự chạy lên được đâu, đúng không? Nhưng mà gạch để trên cao thì nó tự rơi xuống vỡ đâu, đúng không? Thì tại vì là bởi vì cái định luật bảo toàn năng lượng, nếu muốn lên cao thì nó phải tung và nó cung cấp cái năng lượng cơ học để cho cái viên gạch nó đi lên, đúng không? Và cái quá trình đấy là quá trình thu nhiệt, ok chưa? Và nếu cái quá trình đấy xảy ra, thu nhiệt xảy ra, thì cái năng lượng ở bên ngoài ấy, môi trường nó sẽ bị thu vào, và trong quá trình đó thì cái năng lượng, cái nhiệt độ bên ngoài nó sẽ thấp xuống, đúng không? Cái chỗ đấy thì hiểu, đúng không? Thế cái câu hỏi của thầy là điều gì sẽ xảy ra nếu như chúng ta có hai cái mức năng lượng, hai cái vật chất, hai cái chất mà nó ở mức năng lượng bằng nhau? Thế thì hiểu như là bây giờ nếu mà các em để cái viên bi ở trên bàn đấy, nó từ điểm này sang điểm này thì nó sẽ tự động nó di chuyển, đúng không? Tại vì cái năng lượng cần thiết cho cái quá trình di chuyển đấy là bằng không, đúng không? Về mặt nguyên tắc, đúng không? Thế nhưng mà thực tế nếu em để viên bi ở đây thì nó có chuyển sang cái này không? Và ngược lại không? Đây là cái gì đây? Just exercise, đúng không? Thế thì câu hỏi của thầy là về mặt tư duy logic, đấy là cách ở trong lớp học này thầy muốn các bạn tư duy, thầy đặt vấn đề và thầy hỏi để cho các bạn suy nghĩ, chứ thầy không tin. Cái câu hỏi của thầy là nếu như từ trên cao xuống thấp nó tự do, và từ thấp lên cao cần năng lượng, thế thì đến cái quá trình mà chuyển ngang, chuyển cùng một mức năng lượng thì điều gì sẽ xảy ra? Thứ nhất là có cái phản ứng hóa học nào mà cái năng lượng chuyển từ cái mức này sang mức kia nó bằng không hay không? Ok, đúng không? Thứ nhất là có phản ứng nào như thế không? Thì có một phản ứng, đấy là 2H cộng 2 electron bằng hydro H2, thì cái mức năng lượng khác biệt giữa hai cái trạng thái đấy là bằng không. Thế bây giờ theo cái tư duy mà chúng ta vừa nói một cách logic của vấn đề đấy là gì? Từ trên cao xuống đất là tự do, spontaneous, từ thấp lên cao cần năng lượng. Thế hai thằng chuyển ngang thì nó có chuyển tự do hay không? Tại sao?
That everything would happen instantaneously if it just can be freely converting into, two states. If it can freely converting into two states, it's equals to both of them not changing at all. So,
Exactly. Thank you. Then they will quickly establish what we call equilibrium, cân bằng. Okay. Okay. So at the equilibrium. At the equilibrium, okay. At the equilibrium, from outside we see there's no movement. From outside there's no movement. But inside you have the same rate of movement from A to B, B to C, B to A. That means they exchange very fast. But from outside it looks like there's no changing. Okay. Then the second thing I would like to emphasize here is that if you put a ball here on the table, it will not freely move from here to here, right? Even they have the same potential energy. So you expect to have free transfer from this point to this point, right? But in reality, you have a ball here, it needs to answer what we call the anti-force energy. What we call in physics? Okay, massage. Yes. So basically, you need to have energy to answer, to reply this process. So the same for chemical reaction. Actually, the real thing, and that will be very helpful for you to learn the general chemistry 2 class later. If you fix the idea that you have a carbon A here is pulled down directly to this process, then you don't need to pay any energy process, right? The process will be spontaneous. But actually, the reality is that the carbon A is here because it's at this diaphragm. And the B here is at this diaphragm. Okay? So if you want to bring A from here to here, it's not like fall down directly. You need to bring from here up to this position and then fall down. Okay? So you need to pay at least the energy difference. You get what I mean? So even for the K of A and B equal like this, you will have this process. So you need to bring C from here up here before it's fall down. So it's exactly like the case when you have the ball, it cannot move freely because you need to pay energy for this process. Is it clear or not? Okay? Now, then we need to wait. So here is the classification of matter and how you can distinguish the different matter. So you take the matter. The first question is this uniform? If the answer is no, then you have heterogeneous mixture. If the answer is yes, you have homogeneous mixture. And then you ask the second question, does it have a variable chemical composition? That means you can vary the chemical composition of this mixture. If the answer is no, then you have a pure substance. If you have a pure substance, the next question will be, does it contain more than one kind of element? If the answer is no, then you have one element. If the answer is yes, you have a one compound. Okay? And then if the mixture, homogeneous mixture cannot vary in terms of chemical composition, then you have a homogeneous mixture. Okay? So, let's look at this question. 2 minutes. Stainless steel that has corrosion and oxidation resistance are typically made of irons, 0.1% carbon, and 11% of chromium. Could you please classify this matter? stainless steel? Is this homogeneous mixture, heterogeneous mixture, pure substance, element, or compound? Which one could be? You use this kind of steel, stainless steel every day. Thép chống gì, okay? So, how can you classify this compound?
Uniform to
Why is heterogeneous mixture?
because I think it's I use stainless scissors every day to cut the meat.
Okay.
But the reason that my scissor is never up. Because inside the scissor is the iron and outside is covered by chrome.
Chromium?
Yeah, chromium.
No, that's a scissor. I mean, the stainless steel contain irons, chromium 11%, and 0.1% of carbon. Okay? So, we mentioned that you see the iron is inside, and on the surface we have a chromium, right?
Yes.
So in that case, you define like heterogeneous mixture. Okay, thank you. Any other comment?
Stainless steel is homogeneous because it will have a clear border between different substances and it look like it's uniform.
So let me start first. It is uniform throughout. That means it is uniform over the stainless steel. Okay? So the answer is yes. You have every position in this matter, you have the same composition of irons, carbon, and chromium. The case you have iron inside and chromium outside is not real stainless steel. Okay? So the first is that you have yes, so you arrive in homogeneous mixture at least. The next question is, does this have variable chemical composition? The answer is also yes. Maximum of 1% of carbon, but you can have a less composition of carbon. You have 11% of chromium, but you can have less than 11% of chromium. That means you can vary the chemical composition. So the answer is yes. So the question, the correct answer will be the homogeneous mixture. So we can call a solid solution. The liquid solution you know very well, right? You put water inside, dissolve in the you put ethanol inside water, it dissolves. So you have a homogeneous solution. Here you have solid solution. Okay? So we have carbon, which is a solid, chromium is a solid, dissolved homogeneously in iron. Okay, is it clear? So here, few other matter. Beer alloy is homogeneous or heterogeneous mixture? Homogeneous mixture? It's heterogeneous mixture, right? Because inside you have CO2. And the CO2 will continuously evaporate and you can see the bubble inside, right? So it's not homogeneous. Unless you see when you see this position and this position, they are not the same. Okay, so it's heterogeneous. Sulfuric acid is a
homogeneous.
It's a homogeneous. Is a substance. Okay, because it contains three elements: hydrogen, sulfur, oxygen. Okay. Sulfur powder is a element, and the mixture, the crazy mixture you work on already over there is a heterogeneous mixture, right? So I can share with you one very nice experience. That's the year before. For the midterm, my question for the midterm is the air in Hanoi a homogeneous mixture?
No.
The answer is no, right?
Yes.
It's heterogeneous mixture. 1 year later, I changed just Hanoi to Paris. The question is the air in Paris homogeneous mixture? Some people say that if last year he asked Hanoi, this year he asked Paris, the answer should change already. So the answer is yes, the air in Paris is homogeneous mixture. Crazy, right? It's not the air in Hanoi homogeneous, heterogeneous and polluted, and the air in Paris is cleaner, fresher, so it's homogeneous. It's not the case. So think about this, the reality, don't think about the correct answer like the physical way. Go to more interesting challenge. We talk about the separation of the mixture. Imagine that in the optoelectronic, that means the people working to make the television screen and so on. So they combine one common compound, that's biology, know very well, porphyrin. Porphyrin, you know, right? Huh? Porphyrin. This porphyrin compound, the red part over there. And then you put on the one layer graphite, we call graphene. So they have a very strong interaction, what we call the pi-pi interaction. Don't care about this lecture. You have a very strong interaction. Now the question is that if you have this mixture at the end of using in the electronic industry, how you can separate the two chemical compounds? Can any one of you can propose this strategy to separate the two compounds in the mixture? Because it's happened in real industry, not like you have iodine and salts, you put in water, you dissolve, you burn. No, it's not like that. But how we can separate the two chemical compounds? So you look at the physical property and chemical property of the component inside the mixture, right? So first, the question of solubility. If you put this mixture in water, for example, or in other organic solvent, do you think that the graphite, the big one over there, the graphite, will be soluble? If you have one mixture, one compound soluble in one solvent and another not soluble in this solvent, you can dissolve in this solvent, right? So for example, if you take acetone you know very well, especially for the lady who use acetone to wash every day, like this. Then you put in this mixture, you put this mixture in acetone, the rest component will be dissolved, but the graphite will not. So you can separate the two components. My message is that if you want to look at the separation of the mixture or purification of one compound in the mixture, you need to look at the physical property and chemical property of each component. And find the condition that the two components have drastically different behavior in the same condition. So we can separate, okay? One soluble, another not soluble. So I keep this one important. So we move to what we call the chemical chain. A substance, if you have a chemical chain, when a substance is transformed into a chemically different substance. For example, if you take copper, this coil made of copper, you put nitric acid inside. So you see that you generate a green solution, and also on in the above of this copper, you have the brown gas. Okay? So you see that this copper compound reacts with this nitric acid, generate already this new solution and this gas. So you see that one chemical compound already can transform, consume and transform to generate a new chemical compound. At least here you have two, right? So this process is chemical process. Do you know what could be the gas here?
No.
Huh?
NO2, no high.
No high.
Correct?
No,
Yeah,
it's not white.
but there are many options like NO, N2 or N2O. And also the those like NH4 with
So basically you have nitrogen oxide, right? Okay? So, another example, if you have hydrogen and oxygen, you put together, it will spontaneously react to make water. So the process is also downhill process from the higher potential to lower potential. However, there are other things we need to consider. When we talk in this early morning, when I talk about the potential energy, and I mentioned that the higher potential energy fall down easily, but lower potential energy, if you want to bring up, you need to pay energy in, right? When we consider about the chemical reaction, the potential energy, we talk about the thermodynamic. Okay, how the energy of the chemical reaction happens. Another thing you need to consider is that if the reaction happens, but how fast is it? So we need to talk about the kinetic. So in Vietnamese you have the term thermodynamic equal to nhiệt động học. And in the kinetic you have the concept of động học. How fast is moving. Why we need to consider about this? Let's say, if there is one chemical reaction happen spontaneously in terms of energy potential from a higher potential to lower potential. But it takes 100 years to complete the reaction. Then for me it's no use because I die before 100 years. Right? So in terms of application, it's not a question of happen or not happen, but the question how fast is happen. You get what I mean? So here you have extremely beautiful demonstration. If you have hydrogen and oxygen, you mix together. If you mix in a plastic bottle like this, you can keep for 100 years, then no water produced. Because the kinetic is extremely slow. Even the process is extremely exothermic. You get what I mean? But the same mixture, if you put in the metal bottle, it will be explosive. Because on the surface of the metal, the kinetic process happens very fast. And when it happens, it generates heat, and it generates a lot of heat in one time, so you create a form. You understand what I mean? So later, not in my class, but later when you study general chemistry 2, please pay attention to two things. Thermodynamic of chemical reaction and kinetic of chemical reaction. Why I mention that? Because one day we are in a discussion after the international conference. One young professor from a big university mentioned that, okay, if the reaction could not happen because the process is endothermic, from lower energy to higher energy, then we use a catalyst. Then my colleagues asked where this guy graduated from. Because apparently she is brilliant, creative, but she has no background in chemistry. Because if the process cannot happen thermodynamically, you cannot use any catalyst to accelerate the process, right? You put the micro here, and you use any catalyst, and off. Never happen. Okay? So you can use only the catalyst to accelerate the process when the process is downhill. That means from higher energy to lower energy. So first, when you look at the chemical reaction, first you have to say whether thermodynamically is possible. If yes, you consider about how fast is it. If it cannot be very fast, you use what we call the catalyst subtract, right? But if it cannot happen, then you need to think how much energy I need to put in to make it happen first. Right? Is it clear or not? to be honest, after the class, after the general chemistry 1 and 2, you can forget everything. You can, if you pass the exam. But you cannot forget about thermodynamic and kinetic of chemical reaction. Please. Okay? Otherwise, it's like I am a strong guy in mathematics, but I don't know what is triangle. Okay, so again, a substance is transformed into the chemically different substance. Let's say, take this case. If you take the trans azobenzene, this compound, and cis azobenzene, whether the process from trans to cis azobenzene is a physical process or chemical process. Huh? Physical or chemical process. By definition, the chemical process is the process where you have transformation from one chemical compound to another chemical compound, right? Is it clear?
Yes.
One compound will be consumed, another compound will be generated. So, if you look at this case, do you have transformation from one chemical compound to another chemical compound or not? If yes, that is chemical chain. If no, that is physical chain. By definition. So, yes or no? Yes, right? Because you have trans azobenzene, is one compound, and cis azobenzene is another compound with different chemical property. Even they have the same number of carbon, same number of nitrogen, and same number of hydrogen. Okay? So this is a chemical chain. And it chain happens when you put energy in. For example, photon energy. So S nu is photon energy. Okay? And look the beautiful of this chemistry. If you consider nitrogen is here on my body, okay? And this one is benzene. This one is another benzene, okay? This chance is like this, okay? And cis is like this one. So basically, you do the movement like this, okay? So that is the idea of the Nobel Prize in Chemistry 2016. That we call the molecular machine. Machine at the molecular level. Machine is something that absorbs energy, receives energy to do action, to run, right? So if you have a chance like this, you absorb energy, you make this movement. So it's one movement of one enzyme, one machine. Okay? Is it clear? So it looks like you can make this movement by using energy, but at the molecular level. So that's the idea of Nobel Prize in 2016, Nobel Prize dedicated for molecular machine. Okay? So basically, you can imagine one thing. Can you see what could be the movement over there? The up one. So it looks like you have two circles like this. Okay? With the copper inside, the two cycles gets closed like this one. And when you remove the copper, it will be like this. Okay? And this one. So when you have the copper, 2 is going to be this position. When you have the copper 1, the copper 1 is like this, and the copper 2 like this one. So it looks like when you have copper 1 is like this one. When you have copper 2, this ring will transfer. Okay? So we make this rotation. Okay? So that's the molecular machine. The beautiful molecular machine. Where do we have it in our body? All of these muscles operate with molecular machine. Okay? So why I emphasize here? Because if you guys who work in mechatronics, for example, in robotics, okay, you want to simulate all the action of a human body, you need to think about the mass mechanism like this one. Because robots, when you send energy, which is the electrical energy, right? Electricity. You need to convert the electricity to some action to make the movement of the robot. Okay? So who are the bad robots? All of us. Right? Because every day we eat to have energy and to make the movement. So if you want to learn to make a beautiful movement for robots, please consider about the signal you send, the energy you put, and the mechanism how you make the movement. You get it? Okay. Next tutorial question. Exercise. Midterm test. Hydrogen produced by reforming of natural gas contains CO, impurity, which is harmful for platinum catalyst in the proton exchange membrane fuel cell. For example, the car run by Toyota, proposed by Toyota to run with hydrogen fuel. You don't care about this sentence if you want. Let's say if you have a mixture of hydrogen and CO, how you can separate, how you can purify to make hydrogen pure. Because CO is toxic not only for the human body, but toxic for the engine, for the car of Toyota. So during my postdoc stay in CA Genovo, I work in collaboration with Renault. You know Renault, right? The automobile company, French automobile company. And we try to take a mixture of hydrogen with 50 ppm. ppm means parts per million of CO, very small amount of CO. And I put in the catalyst, which have the catalyst from Toyota. So we know, want to ask question how the Toyota catalyst can survive in the condition with 50 ppm of CO. And we figure out that with 50 ppm of CO, the car will stop at 15 minutes of operation. That means you run the car, quarter hour later, it will stop. So, where the question is important, how you can purify hydrogen to remove CO. And I can tell you that in France now, there is one big institute only dedicated to work on this question. And in Asia, the leader absolute in the industry to make clean hydrogen, to purify, remove CO from hydrogen, come from Taiwan. Okay? So it's already happening in the market. The technology is already available, but very expensive. So now back to the general chemistry question. You have a mixture, hydrogen and CO. So you can have a homogeneous mixture, right? How can you remove CO to get pure hydrogen? 2 minutes. Do you understand the concept? Okay, this. With all the idea about the mixture, chemistry, whatever you want, try to propose a technological solution to remove CO to get pure hydrogen. Please, 2 minutes. You can discuss.
Làm thế nào để lấy được CO ra khỏi H2? H2 product by forming natural gas contain CO equal harmful cause. It's a energy to eliminate from high gas. Lấy CO ra khỏi một hóa bây giờ học hóa.
Hydro được tạo ra bởi biến đổi khí tự nhiên.
Không phải sao nó theo của oxy được. Bây giờ mình đang muốn